This is Heliox, where evidence meets empathy. Independent, moderated, timely, deep, gentle, clinical, global, and community conversations about things that matter. Breathe easy. We go deep and lightly surface the big ideas. Welcome back for another deep dive. Today, we're going to be tackling something I think is pretty fascinating. How our brains react to emotionally charged words.
Oh, yeah.
You know, those words that make you feel happy or sad, angry, like all the feels.
Yeah.
So we're diving into this really cool study by Batten and their team, published just this year in Cell Reports, called Emotional Words Drive Decisions and Behavior.
Right.
And I think what makes this research so interesting is they actually measured levels of dopamine, serotonin, norepinephrine while people were processing these words. So these are those chemical messengers in our brains. Wow.
Exactly, yeah. So it's not just looking at brain activity in general, but this study is kind of getting down to the nitty-gritty of the chemicals involved, giving us a more, I guess, direct view of the nuts and bolts of our emotions.
Okay, so walk me through like how they actually did this. Did they just like ask people, you know, how do you feel after reading the word sunshine versus like doom?
It was a bit more involved than that. So they had two groups of participants who were already in clinical settings, which allowed for some really unique measurements.
Okay.
So one group was people with essential tremor undergoing deep brain stimulation surgery.
Okay.
And this surgery involves implanting electrodes in a specific part of the brain, the thalamus.
Right.
And during this procedure, researchers were actually able to measure those neurotransmitter levels directly.
So they took advantage of a pre-existing situation.
Exactly.
To get this data.
Yeah.
That's pretty ingenious.
Yeah.
What about the second group?
So the second group was individuals with epilepsy who were being monitored in a hospital.
Okay.
And this monitoring allowed researchers to measure neurotransmitters in a different area of the brain called the anterior cingulate cortex, or ACC.
Okay.
Which, as you know, plays a key role in how we process emotions and make decisions.
Oh, interesting. So two different brain areas.
Yes.
Okay, so what were they having these folks do?
They used a word task, very similar to that classic Stroop test where, you know, you see a word written in a different color and have to name the color, not the word.
Right, right.
But the twist here was that the words shown to the participants were either positive, negative, or neutral in their emotional valence.
Okay.
So think sunshine, doom, or even something like chair, which would be considered neutral.
Right.
The participants were asked to focus on identifying the color of the word.
Okay.
But in the background, their brains were also processing the emotional meaning.
Ah, clever. So that's how they could peek into those emotions bubbling up.
Exactly.
Okay, let's get to the results. What did they find in the thalamus? Now, that's the area involved in movement, right?
Right.
I'm not sure I see the connection to emotions.
And that's where it gets really interesting. So you wouldn't typically think of the thalamus as being a, key player in emotions.
Right.
But remember, the brain is this incredibly complex network. Everything is connected. So they actually ran two versions of the task. In one, the emotional words were presented randomly.
Okay.
And in the other, the words were grouped by their positive, negative, or neutral valence.
Okay.
What they found was that when the words were random, meaning the participants couldn't really predict the next word's emotional flavor, you could say,
Okay, yeah.
the levels of norepinephrine actually decreased as the words got more emotionally intense.
Huh.
Yeah, it's like the brain was surprised and went, whoa, hold on a second.
So maybe norepinephrine is involved in processing that, like surprise or the unexpectedness. When you read a word that suddenly shifts the emotional tone,
Exactly.
and then your brain releases less norepinephrine.
That's a great way to put it. And get this, when the words were grouped by their emotional tone, meaning the participants knew what kind of word was coming next, that norepinephrine effect completely disappeared.
So it's like your brain gets used to the pattern.
Exactly, yeah. Like it doesn't need to react as strongly.
That makes sense. If, like a negative word is coming next, your brain's not as surprised by it.
Yeah.
Okay, what about the other neurotransmitters? Any juicy findings with serotonin, the one often linked to mood?
Right. So they found that serotonin levels in the thalamus actually increased when the participants saw positive words.
Okay.
Which does, fit with some of the current ideas about serotonin being involved in processing those good vibes.
Okay.
But, and this is a big but, they also saw a trend with dopamine.
Okay.
often associated with reward,
Right.
decreasing as the words became more positive.
Wait, so more positive words, less dopamine?
Yeah,
That seems counterintuitive.
exactly. It challenges that kind of simple view of dopamine equals happiness.
Right.
And that's what makes this research so cool. It's showing us that we can't just box these neurotransmitters into these neat little categories.
So we've got the thalamus, like, throwing us some curveballs here.
It is.
What about the anterior cingulate cortex? That other brain region they looked at. What was happening there?
Well, buckle up, because that's where things get even more fascinating,
Oh, wow.
especially when we start to look at dopamine.
Okay. Okay, so dopamine, anterior cingulate cortex. Fascinating. Tell me more.
Well, remember how dopamine was showing that weird trend in the thalamus,
Yeah.
decreasing as the words got more positive?
Mm-hmm.
Well, in the anterior cingulate cortex, it got even weirder, even more complex, I guess.
Okay.
The change in dopamine actually depended on which side of the brain the measurement was taken from.
Wait, hold on. You mean, like, my left brain and right brain could be reacting differently
Yes.
to the same word?
It's the same word.
That's wild.
It really is. So they found that dopamine actually decreased in the left hemisphere when positive words were shown, but it increased in the right hemisphere when they saw those same positive words.
So is my left brain, like, a total downer?
Not necessarily. So there's this idea of hemispheric specialization in the brain,
Okay.
where different sides kind of have different strengths.
Mm-hmm.
Some research suggests the left side is more involved in processing positive emotions, while the right side handles the negative ones.
Okay.
So this dopamine finding could reflect that underlying difference.
So it's not just about the word itself, it's about what part of my brain is processing it.
Exactly.
What about serotonin in the anterior cingulate cortex? What did they find there?
So serotonin also got really complicated in this area. It was modulated by word valence,
Okay.
but also by the participant's reaction time.
Okay, so how fast I am at naming the color
Yeah.
affects my serotonin, even if it's a neutral word.
Yeah, so it wasn't just about whether the word was positive or negative, but also how quickly the person responded to it.
Okay. So if I'm, like, slow on the uptake, my serotonin reacts differently
It seems that way.
than if I'm, like, quick.
Yeah,
Oh, that's like my brain is running a race against my emotions.
exactly. And it adds another layer of complexity to how we understand these neurotransmitters, right?
Right.
It's not just this neurotransmitter equals that emotion.
Right.
These chemicals are constantly interacting with each other and with our thought processes to create that whole tapestry of emotional responses.
So it really makes you rethink those, like, simple explanations. You often hear, right, like, this neurochemical means this.
Right.
It seems like the balance between them is way more important.
Yeah, I think so.
What about norepinephrine? Any changes there?
So unlike the thalamus, norepinephrine in the anterior cingulate cortex didn't seem to be directly tied to whether a word was positive or negative. However, there was a trend suggesting it might be involved in processing the intensity of the emotion, something we call arousal. And this, too, might differ between the left and right hemispheres.
And arousal in this context, remind me, we're not talking about, like,
Right. No, it's not like excitement or anything.
Okay.
It's more about the strength of the emotion a word evokes. So think of words like ecstasy or terror.
Okay.
They really grab your attention. They trigger a much stronger reaction compared to, calm or mild.
Okay, got it. So norepinephrine is involved in how intensely my brain reacts.
It seems that way, yeah.
Not just if it's positive or negative.
Yeah.
And this could be different between left and right hemispheres.
Right.
So, like, each side of my brain has its own emotional volume knob.
It's a fascinating dance of brain activity and chemicals, that's for sure. And it really emphasizes just how dynamic and complex our emotional responses are.
It seems like this study is, like, throwing out those textbook explanations
It does.
of how our brains handle emotions. Like, what are the key takeaways here? What should our listeners really remember?
Well, I think the biggest one is that even a brain area like the thalamus, primarily associated with movement, seems to be playing a role in processing emotional language.
I have to admit, that one really surprised me. Like, why would a motor area care about how a word makes me feel?
Yeah, no, right. But it really underscores just how interconnected different parts of the brain are. This study suggests the thalamus might be helping to evaluate the emotional weight of words and then integrate that information with other brain processes.
Yeah.
It's not just about moving your hand, it's about understanding the world around you, including the emotional landscape of language.
Wow. So even, like, the word happy sets off this chain reaction in our brain.
It seems that way.
And all these different areas are involved in like deciphering its meaning and its impact. What else should we take away?
I think the other big takeaway is that we need to move away from this idea that each neurotransmitter has a single fixed role. Dopamine isn't just about reward, serotonin isn't just about mood, and norepinephrine isn't just about stress.
Right, right. Like this study really blew that view out of the water.
Yeah.
They found these different patterns, different brain regions. It could vary depending on the word's intensity, the person's reaction time, even which side of the brain was processing it.
Exactly. It highlights the importance of looking at the big picture, the whole orchestra of brain activity, rather than focusing on individual instruments. We need to understand how these neurochemicals work together, in specific brain circuits to shape our experiences and guide our actions.
It's like trying to understand a symphony by listening to each instrument in isolation.
Yeah.
You might get a sense of the individual melodies, but you miss the richness and the complexity of that full orchestral sound.
That's a perfect analogy. Our brains are constantly conducting this intricate symphony of neural activity and chemical signaling.
Wow.
And this research gives us this tiny little glimpse into how that symphony plays out when we encounter the emotional power of language.
This is mind-blowing stuff. It makes you wonder about the implications for how we understand ourselves, how we communicate.
Absolutely. And that's something we'll delve into as we continue this deep dive. Stay tuned.
So we've been on this incredible journey, deep into the brain, looking at how these neurochemicals are reacting to emotional words.
It really makes you appreciate the complexity of communication.
Yeah, and it makes you realize, how much is happening under the surface when we're talking to each other. We often say words have power.
Yeah.
But this research really drives it home. Our brains are evaluating the emotional weight of words.
Yeah.
Even if we're not really aware of it.
Exactly.
And so, what does that mean for how we interact with each other?
Right.
How we interact with the world around us?
It raises so many interesting questions.
Yeah.
If our brains are kind of wired to react to the emotional intensity of words, could this explain why certain types of communication are more effective than others?
Think about persuasive speeches or advertising campaigns that really grab our attention,
Right.
Evoke those emotions.
Exactly.
Could this research help us understand why those messages stick with us?
Yeah, it's definitely a possibility. Understanding how our brains process this emotional language could give us insights into how to craft more impactful and persuasive messages.
But that also brings up some ethical questions.
It does.
If we know how to trigger those emotional responses, should we be using that knowledge?
Right.
And if so, how do we do it responsibly?
Exactly. It's like any powerful tool, right? It can be used for good or for ill.
Yeah.
We need to be mindful of the potential impact of our words and use them wisely.
Yeah. This whole deep dive has been a real eye-opener for me.
Yeah, it's fascinating stuff.
And it makes me want to be more careful, I guess.
Yeah.
About the words I'm choosing and how I'm interpreting the messages that other people are giving me.
Absolutely. This research really empowers us to be more aware of the subtle ways in which language can influence us, both consciously and unconsciously. It's a reminder that words have power, and we have a responsibility to use them thoughtfully.
Before we go, I do want to touch on those limitations that the researchers talked about, that small sample size, the kind of unique participants they had.
Right. Yeah, it's important to keep those in mind. This research is really just a starting point. More studies are needed to confirm these findings and explore them in greater depth.
But even so, this study offers some really groundbreaking insights
Absolutely.
into how we process language.
Yeah, it's like a new frontier in understanding communication and the human experience.
It's a really exciting time to be studying the brain.
It is.
With all the new technology, neuroimaging and everything, we're really starting to unlock all these mysteries of how we think and feel and interact.
And with those discoveries comes the potential to really improve our lives and build a better future.
That's a great point. This research has given us a glimpse into the power of words and the responsibility we all have to use them wisely.
Absolutely.
So next time you're listening to a speech or reading a book or even having a conversation with a friend, take a moment to think about the incredible complexity of your brain and the subtle ways in which language might be shaping your experience.
A great reminder.
This has been an amazing conversation.
It has.
We hope you've enjoyed this deep dive into the world of emotional language and the brain.
Absolutely.
Until next time, stay curious and keep those conversations flowing.
Thank you for being curious and subscribing, following, liking, rating, and reviewing our podcast episodes. Your support really helps build a vibrant Heliox community.